Hello everybody. Today we're going to be looking at example 5 for exponential models in your MAT043 workbook. That's on page 111. It deals with Earth's atmospheric pressures. What we're going to be doing with that is creating a graph in Excel and using Excel to help us create the equation using a trend line. Okay, so let's go ahead and look at that. So you can see here I have the workbook page open with our information and our data. And in your lesson, you should have an Excel file that you can open, and it will look like the one I have here on the screen. So I'm just going to maximize that Excel file because it has all the information you're going to need in it. Okay, so you can see we have our data from the worksheet. We are going to be using this data to create a graph. So let's go ahead and start by creating our graph. To create your graph, you want to highlight all of your given data. Now, if this table had some extra places where data was missing, we would not use those. You can only graph items where you have two data points. So that's why we're using these data points here. We're going to go up to Insert, go over to our charts. We're going to use a scatter. We're just going to click that first one that doesn't have any labels or lines or anything. And move that over here where they asked me to put my graph. Make it a little bigger so we can see all the points a little better. You can see how it's got a curve in it. So it's going to be an exponential graph. Now to create your trend line, you're going to want to right click on any one of those points. It doesn't matter which point. Right click, and then from that drop down menu we're going to select Add Trend Line. This is the only way you're going to be able to get your equation. So select that Add Trend Line, and it automatically gives us a linear first. So I'm going to go over here. I want it to be exponential. I want it to display the equation because we're going to be using that, and also display the r squared value. Okay. That r squared value tells us how good our graph is, or our line is. I'll make that a little bigger so you can hopefully read it a little better. Okay, so you can see my equation there, and you have my r squared. So that 0.996 is basically saying that it's a pretty close to 99.66% accurate, that line. Or that curve. You can see it doesn't really touch all of my points, but it comes very close to being in the center of all the points. So it's a very good line. We want that r squared value to be as close to 1 as we can possibly get it. Okay, so for part B, your worksheet asks you to, after creating the graph, determine the equation of the exponential function. Okay, so the exponential function, okay, is basically right there what Excel gave us. So we're just I'm going to type that in over here. So y equals 1081.7 e, and that is raised to the negative 0.147x. Now that e value, that is a special number or value. It's very similar to pi. Make that a little bigger so you can see the equation I put there. It's a set value. It's called Euler's number. So when we write our equations, though, in 043 and 143, we do not use this format. We use Q form. So on page 112 of your workbook, it talks about Q form, and we've done a little bit of Q form already in this lesson. So our Q form is that Q equals Q sub 0, 1 plus or minus R, quantity raised to the T. That's our Q form. So we need to change the Excel form we have with Euler's number there into our Q form. And your workbook goes into that. I'm going to walk you through it. So what we really need to do is change that exponent part. And we're going to use the exp function in Excel to do that conversion. Okay. So I'm just going to do it over here to the side, maybe right above. That'll be fine. And do equals exp and parentheses, and then we put the exponent number that was on Euler's number or on our E, which is that negative 0.147. And then end our parentheses. Don't put any variables or anything, just the coefficient, just the number value. Okay? That is going to give us our growth factor. Okay? So that value right there, that 0.8633, or sorry, 8632494, that's our growth factor. That's not the R. That's what happens if you do 1 plus or minus R. Okay. Now, since this is a decay, we can see here in our graph, then this is going to be a 1 minus R. Okay. So when I do my Q form, if I want to, I can go ahead and write it to begin with as one piece. Okay. So this would be Q equals, our initial value is going to be the same as what they gave us in the Excel equation, 1081.7. We'll have our parentheses, and then our growth factor, which is the 0.863, and I'm around to 4 decimal places. That's normally what we round to, 3. And then that would get raised to, in this case, we're doing altitude, so I'm going to use A. Because it's not time, it's altitude. So just remember that that exponent does not always have to be time. Okay, it's just how much it changes by each interval. Okay, so that's what it would look like if we had the 1 plus R put together. Now, so remember for your MAT043 class, they're going to want you to split this so that you have the 1 plus or minus whatever your R value is. Now, since this is decay, okay, our decay factor would be equal to 1 minus R. Remember, if it was a growth factor, it would be the growth factor equals 1 plus R. But since this is a decay and it's going down, it'd be 1 minus R. Okay, so I could put that in as 0.863293977 equals 1 minus R. Okay. And then I can do the math to solve that equation to solve for R. When we do that, you should get R to equal 0.136706, and that keeps going. Again, we're only going to go to 2 decimal places. Now, when I did my converting, you'll notice I put in all the decimal places I could. Okay, that's because you want to save the rounding until the very end. Okay, so the Q form, as your 143 instructor probably wants it, will look like this: Q equals 1081.7 parentheses 1 minus, and then we'd have 0.1367. And then that would get raised to my variable. Again, I'm using A since altitude is what it's changing by. And actually, instead of P, we could do, or instead of Q, we could do P. So we can say the pressure. So we can write it more as a function. In fact, as a function, this would look more of P of A. So the pressure at a given altitude. And then we would have the rest of our equation there. Okay. So that is example 5 from your workbook, and you can use this to help you as you're working through your other problems and your practice problems.